There are millions of bacteria on our planet, each with a specific name to help identify it. Now, how do scientists differentiate between each bacteria from one another? Well, the answer is simple. Dichotomous key and a series of tests. Okay, this may not be so simple. What's a dichotomous key? Don't worry, I got you covered there. But first, I'm going to lay out the main points for you. The first point, what is a dichotomous key and how do we use it? Second, why did we choose the test that we chose? And third, how are we able to interpret the results from our tests in the hopes of identifying our unknown bacteria? Alright, well, before we get started, I just want to let you guys know that the bacteria we're dealing with, you don't know what it is, and I don't know what it is. So, this is essentially a blind test. But, if we use a dichotomous key, we're able to not be so blind. Kind of essentially putting some glasses on and helping us see what the bacteria is. So, first, I have 4 bacteria that will be tested that could be any of the unknowns. We don't know. So, each bacteria has its own characteristics that are expressed when performed under each test. Now, from this, we're able to kind of see like what bacteria have certain outliers, like maybe one is able to produce an acid and the other ones aren't, or maybe one's a different shape than all the rest. So we call these like kind of outliers, and this is how we kind of base our dichotomous key, which is essentially a flow chart, where at the top we got our unknown, and from here it forks, and right here, right at the middle of that fork, is our first test, and this will determine which path we're going to take down the road. So, the first test we're doing is a simple shape test, where we look at the bacteria under a microscope, and on one side it can be bacillus, which is a rod shape. On the other, a coccus shape, which is more of a circle. So, if we look at our characteristics, we see that one has coccus shape and the other 3 have bacillus. Well, if life was easy, this bacteria would choose to be a coccus shape. Didn't happen. So, check that one off the list. Goodbye coccus shaped bacteria. Now we're down to 3. So we go down our dichotomous key now. We're going down this path, not that path. So we go down this path. Here comes the second fork in the road. This time, we do a different kind of test. A sucrose fermentation test in a phenol red tube. What's that? Well, in a sucrose fermentation test, we subject the bacteria into the test tube, fill with sucrose, and kind of agitate it, let the bacteria kind of make sure it kind of settles in there and it's not on our loop. And we want to see in a day or two, so what we do is first agitate it, let it sit, go put it in an incubator at 37 degrees Celsius, come back in a day, look at it, and if the bacteria is able to ferment in sucrose, there should be an acid forming. But how do we know if an acid formed? Well, it's a pH indicator. So, if an acid formed, the tube goes from a red color, being neutral, to a yellow color. And if we look at our list, only one produces an acid. So, fingers crossed, maybe it produced an acid. Well, upon doing the test, we find no acid formation. So, check that one off. Goodbye acid forming bacteria. Now we're down to 2. E. coli and Pseudomonas aeruginosa. We're going to duke it out here in the third test. So the third test that we're going to do, if we look at our characteristics again, we see that there's a test where one is positive and one's negative. This is ideally the test we want to choose for our dichotomous key, and it happens to be a citrate test. Again, what's a citrate test? What it is another pH indicator kind of test, but it's in an auger slant tube this time. So we take some of our bacteria from our petri dish, but before we do that, you got to sterilize your loop. Key in microbiology. Sterile. Keep everything sterile. Otherwise your cross can't contaminate and you get some bad readings on your results. So after you sterilize your loop, preferably by throwing it in a Bunsen burner for a little bit, letting it heat up and then cooling down just so you don't burn your auger. So then you get your loop full of bacteria and you poke it into the little tube slant and then kind of scribble down it. And after scribbling down it, you let it sit in the incubator for a day. Now, if it's positive, the blue auger with the bacteria on it should turn a green almost on the surface. But if it's negative, it will remain blue. Well, upon doing this test, we find that the tube stays blue. The test is negative. So let's take a look at our dichotomous key and our characteristics. Looks like our winner is E. coli. So, just to reiterate what has happened, we were able to use a dichotomous key to help us choose the tests to be conducted on the bacterium to eliminate outliers based on their characteristics. Now, collectively, the results of each test helped us in finding our unknown, which happened to be E. coli. So, I hope that my presentation kind of clarified how scientists are able to identify an unknown bacteria from a list of some bacteria. In most cases, it's going to be a lot more than that, but this is more of just a simple kind of an intro into microbiology tests. Thank you.